Hello everyone. In this video, we're going to talk about something known as direct variation. So let's start by talking about what direct variation is. A function in the form of y equals k times x, where k is not 0, is a direct variation. K is what is known as the constant of variation. Constant of variation. K is the coefficient of x, whatever it may be. The variables x and y are said to vary directly with each other. And just a general note, constant means remaining the same. The constant of variation means changing at the same rate. For y equals kx, y is a function of x. We've been talking about that in the last several videos. If x is 0, then y is also 0. So the graph of a direct variation is a line that passes through 0, 0, or more commonly known as the origin. To tell whether an equation represents a direct variation, we solve for y, and that's really all we do. If the equation can be written in this form, y equals kx, it represents a direct variation. So let's take a look at a few examples. So what we want to ask ourselves is this: is each equation a direct variation? And if it is, we're going to find the constant of variation. So all we do is solve for y. We want to get y term by itself, and in that form, y equals kx. So we'll start first by subtracting 5x from both sides, canceling it out on this side. Last thing we do here is divide by 2. Cancels that. Here we have y equals, this is negative 5 over 2, or 5 halves, x. This equation has a form of y equals kx. K is allowed to be negative, that's fine, it just can't be 0. So this is a direct variation, and the constant of variation is negative 5 over 2. And that's it. Let's look at one more, this one right here. Same exact approach, we're going to solve for y. Let's start by taking away 4x from both sides. Now we're going to divide everything by 3. Here this gives me y equals, hold up there, all right. This gives me negative 4/3 x plus 8/3. This equation cannot be written in that direct variation form, so it is not a direct variation. You can't have any additional terms paired with this in order for it to be a direct variation. It must only be just the one variable, the constant of variation, and no additional terms. So this one is not a direct variation. Not a direct variation. I'll just show you that here. Not a direct variation, whereas this one is. Because again, we had that form y equals kx. K is the constant of variation, so this one is a direct variation. Now, is there another approach to writing the direct variation setup here? There is, and I'll show you in the next video where we will work with ratios and proportions for direct variation. Thank you so much for watching, and I will see you later.